All right, we're live. So, right now we're going to prove the Pythagorean Theorem. Notice how it starts out. It says, given that triangle ABC is a right triangle, and then it just names the sides. It wants us to prove a squared plus b squared equals c squared. All we have at first is just this blank triangle. Your first step, if you look here, is to draw a perpendicular from C to the hypotenuse, and then label that point intersection X. So the first thing you do when you have a blank triangle like this is you're going to do this sketch, and you're going to go right there, that's 90 degrees, and you label that X, which is what they did right here in this step. Now, draw a perpendicular. What is another word for this right here? You can talk, it's all right. Remember, it's not the bisector. It's not the perpendicular bisector.
It's the altitude.
It's the altitude. Very good. So you have to know that that is interchangeable. We are drawing the altitude. Another word for altitude is? Height. Awesome. All right, now by doing this, we've created three similar triangles. We have a small, we have a medium, and then we have our OG original, the large. Small, medium, and large. All right, erase. The first thing it says is that angle BXC, that is this guy right there, what triangle does that belong to? The medium. Is congruent to angle BCA, which is here. Which triangle does that belong to? The large. What is the measure of both of those angles? 90. So our reason for being able to say that they're congruent is because all right angles are congruent.
90.
They're all congruent. It's kind of silly. The next thing it says is that angle B is congruent to angle B. Angle B is in both the medium triangle and in the large triangle. So angle B is congruent to itself. What is our reason for that?
Reflexive.
Reflexive property. Reflexive. I spelled it right. Now it's saying, so the BXC, which is the medium triangle, is similar to the large triangle. And what is our reason for being able to say that?
AA similarity.
Very good. It's AA. Angle, similarity. Nice work, guys. Actually, here we go. We can leave that up there. The next thing it says, oh, that's too high. I can't reach. We now have angle AXC, which is this guy right here. So what triangle does that belong to?
Small.
That is the small triangle. Awesome. Well, it's off a little bit. A lot. Oops. That's right. That is congruent to ACB. So ACB is here. What triangle does that belong to? The large. So we're now looking at the small to the large. They're both right angles, so what's our reason for being able to say that?
That all right angles are congruent.
Good. All right angles are congruent. Next, it's saying that angle A is congruent to angle A. So again, angle A is in the small triangle, and it is also in the large triangle. Let me erase this so we can actually see it. There we go. What's our reason for being able to say that? Color. Now it's saying, so triangle AXC, which is our small triangle, is similar to our large triangle, and our reason is angle, similarity. Side note, okay? We have proven that the medium is similar to the large and the small is similar to the large. What can you say from that?
The small and the medium are similar.
Very good. The medium is also similar to the small. They are all similar to each other. On that note, okay, you prove the medium to the large and the small to the large. Does it matter if I started with the small similar to the large instead? No, not at all. But that's what you do. That's the process. Now from there, guys, we're going to set up proportions. Get rid of all that craziness there. Oh, when we drew this right here, notice how we split the hypotenuse into that little guy and this little guy? Okay? What they did here is they labeled this little guy D and this little guy E. See, D, E. All right? And the whole thing is still C, of course. So this says for proportion 1, because triangle BXC is similar to BCA, so BXC, we're looking at our medium triangle to our large triangle. The first fraction is A over C. So it's this over that. What triangle is that?
Large.
The large. Here's what we need to understand, all right? B, this guy here, that's the small side. Okay? C is your hypotenuse, the large side, and A is your medium. Awesome. So what we did here in this first fraction is we looked at the large triangle, and then on the top we have our medium sides, and in the denominator we have our large sides. All right? So now we have to keep like with like. We're going to look at our medium triangle. The side that has to go on the top is the medium side in the medium triangle. So this right here, that's the small side. A is the
medium side.
A is actually the large side. A is the height, because there's your right angle right there. Okay, so, and they actually have that one down. So E is your medium side. That one's a little tricky to look at. All right, so here on the top, we're going to put E. Now we're going to look at proportion 2. Because triangle AXC, so that is our small guy, is similar to the large guy, we know B over C, so let's check that out. So we have B over C in the large triangle. So again, we're starting with our large triangle. Which side is on the top again? The small side. And which side is on the bottom? Large side. Now we're going to look at our small triangle. So our small side in our small triangle is D. And then of course, you can already use blue there. Our hypotenuse in the small triangle is B, but they already have that for us. So real quick, let's talk about how we set up these proportions. When you're talking about the large triangle and the medium triangle, you are going to use the large sides and the medium sides. You keep like with like, okay? This is how you can remember. Then you talk about your large triangle and your small triangle, so you're going to look at the small sides and the large sides. All right? That's how to keep that straight. The small and the medium, you're never going to set up a ratio with those. You don't need to. All right? Next it says, now perform some algebra to complete the proof as follows. I'm going to get rid of all of this. We don't need it anymore. Actually, let me get rid of this. I'll rewrite that D. Rewrite all this. This is what, E and then D. Okay, I'm going to switch what this says too. It says, multiply both sides by AC for proportion 1. We're not going to do that. Get rid of it. I want you to write cross multiply. Cross multiply. So if we go back to proportion 1, look what's going to happen right here when we cross multiply. What's A times A? It's A squared. And then here, C times E is just CE. We'll do it alphabetically. We're going to do the same thing with the next one. Cross that off, and so we're going to write cross multiply. we have b times b, which is
B squared.
b squared. And then c times d, which is just
CD.
CD. We're looking good. Oh, look at how high that 2 is there. That's kind of weird. I don't know if I like that. Oh, that wasn't much better. Whatever. All right, now it says adding the above equations gives us this. So this is pretty cool, guys. We're just going to add these babies up. So on the left side, we are going to have a squared plus b squared. On the right side, we are going to have CE plus CD. Okay, and literally in the proof, your reason for that is just adding, addition property. That's fine. Next it says factor the right side of the equation. So notice how they both have the C. We're going to actually pull out a C. We're going to factor it out. So if I take out a C, what am I left with here? E. Right here, if I take out a C, I'm left with D. Nice work. Now we're looking good. Oh, by the way, your reason for factoring, that's the distribution property. Okay? Finally, use the fact that E plus D is equal to something by the segment addition postulate. So we're actually going to go back up and we're going to look at this. Again, it says E plus D. So if we look here, what they're saying is this plus this is equal to
C.
C. It is equal to the whole thing. I'm just adding the segments. So I'm going to say C right here, and of course that's segment addition postulate. Then it says to rewrite the equation as
A squared plus B squared equals C squared.
B squared is equal to C squared. So understand what happened. We took this C right here. Because E plus D is equal to that, we went back into this equation, and where we saw E plus C, we put C. What property is that? Substitution. So the last substitution, I made it. And then of course you multiply your C times your C, and you're done. Wait, oh, you know what? We'll do one more go over, just to reiterate. First step, you draw a perpendicular or your altitude, whatever you want to call it. From there, you say that the medium triangle's right angle is congruent to the the large triangle's right angle. Then you talk about the angles that they share. You do the same thing with your small triangle to your large triangle to show that they are similar by angle-angle similarity. From there, you are going to set up proportions like so. Okay, you do the medium to the large triangle, and you look at the medium sides to the large sides. You do the small to the large, and you talk about the small sides to the large sides. You then cross multiply. Oh, that looks weird. To get this, you add the equations, and then you use segment addition to replace E plus D with C. And you substitute that in. And that is it. Now we can...